Okay, in this video, I'm going to show you how to integrate e to the negative x dx. Now, if this is e to the x dx, then the integral is simply e to the x plus c. But for the case of e to the negative x, you don't say that this is directly e to the negative x plus c. The rule for e to the x only works when this is just x, not 2x, not 3x, not even negative x. Now, so how can we use the rule that the integral of e to the x is itself? We can do that by the method of substitution. Okay, so we use substitution before we can apply the integral of e to the x. So first, if you notice, or if you can see it, it's negative x. So one way to make this look like e to the x is to let u be the negative x. So if u is negative x, then du is equal to negative 1 dx, or simply negative dx. This means that negative du is equal to positive dx. Okay? So with this, the integral of e to the negative x dx can now become integral of e to the u, because x is, or u is negative x, and then dx is now changed to, so take note that dx is equal to negative du. So you have negative du. But negative du and e to the u means integral of negative e to the u du. At the same time, integral of negative e to the u is also the same as negative integral of e to the u du. Now at this point, you can see that it's like e to the x dx. So the rule for e to the x can now be applied. So the integral of e to the u will be itself. So it's e to the u and then plus c. But we started with the given that is e to the negative x dx. So that means the u should return to its original value, which is equal to negative x. So finally, this is equal to negative e to the negative x plus c. Now if you take a look at this, so it seems like it's a long solution, but try to analyze if we have e to the 2x dx. Because from e to the negative x, the integral is like e to the negative x, except that there's a negative 1 before e to the negative x. Now, we already know this is the answer. Okay, this is the answer. But what I want you to understand is, what if I change negative x into a different expression, such as 2x? So let's try it again. So this time, a good option for you is 2x. Okay, so if u is equal to 2x, then du must be equal to 2 dx. That means du over 2 is equal to dx. So what will happen to our integral of e to the 2x dx? So by substitution, we have e, the 2x becomes u, because we said u is equal to 2x. So if it's u, then dx on the other hand, so focus here, the dx is equal to du over 2. So that means dx is now changed to du over 2. Take note that this is the same as e to the u over 2 du. At the same time, this is also equal to integral, so you can put the 1/2 outside, it's a constant rule, then e to the u du. At this point, it is now like e to the x dx. So the integral of e to the u is also e to the u and then plus c. So this is equal to 1 half e, but the u is equal to 2x, so you have to return the 2x and then plus c. So the pattern that I want you to understand is that we started with, so take note, we started with e to the 2x dx, and the answer is 1 half e to the x plus c. If we integrate e to the 3x dx, the answer is 1/3 e to the 3x plus c. Do you see the pattern? If I will integrate, so if I will integrate integral of e to the 4x, what do you think will be the result? If you say that it's 1/4 e to the 4x plus c, then that means you're correct. Okay? So can you see the pattern? Now, going back to the e to the negative x, this should be faster now. So this is 1 over negative 1 e to the negative x plus c. That is why we ended up with, this value. So you have, so this value is equal to negative e to the negative x plus c. So I want you to observe the pattern. So from here, so we have, so a while ago when we were simplifying, or we were integrating e to the 2x, it's 1 half e to the x. E to the 3x is 1/3 e to the 3x. E to the 4x is e to the 4x, 1/4 e to the 4x plus c. So e to the negative x is negative e to the negative x plus c. Okay? So in general, so let's generalize this. If this is e to the nx dx, where n is any number, so the integral will be 1 over n e to the x plus c. So you won't have to do long computations anymore. But if you want to use this technique, you have to remember that that is the integral of e to the nx. Okay? That's it. So in the next example, I will be showing you a problem containing e to the negative x. But since you know already how to get it directly, then it will become faster the moment the expression becomes more difficult. So you will see that in the next example.